Hello everyone out there, welcome back to the Oberon Channel, and sorry for the delay because my last episode is some months ago. I had a lot of private things to manage and the free time is becoming less and less, you know. And that's a common phenomenon for everyone who lives in the world of today and has to find a compromise for private issues and doing a job. So it's not getting easier, but I want to present you a very interesting episode now because I did some researches on the USB system in Oberon, because my goal was to connect a thumb drive like this to the Oberon system, and I tried it. It was like a shoot from the hip, you know, to get this working, and it didn't work. And after a while I found out that I have to dig deeper in the secrets of the Oberon system regarding the USB functions, and well, so I did. The problem with those USB thumb drives is that they generally are recognized by Oberon, but Oberon does not know the file system these thumb drives normally use, because, you know, the FAT32 file system is the standard for this one. Even when you put this on a Linux device, normally this system expects that these thumb drives are formatted in FAT32. Unfortunately, when Oberon was designed, FAT32 was not existing. So that was really an issue. After digging through all the documentation of Oberon and understanding a little bit of how the USB system and the mass storage system in Oberon works, I finally came to the point where I had to decide to write a FAT32 driver for Oberon, and this is quite a challenging issue. But I found a way to overcome this, and the solution is very easy, because it's possible, I didn't know that is, but it's possible to format these USB drives in FAT16, the old DOS file system format, you may know. So it's just an issue because the structure of the file system is a little bit different, and it's not so efficient, and the size of the partition is limited to 2 gigabytes, but that's far more than enough what you need for an Oberon system, because you have more place for storing your data than the whole size of the system is. So reformatting those thumb drives in FAT16 was the solution. The downside is that I discovered that not every thumb drive works in a way that's suitable for Oberon. I don't know why this is so. I think that's maybe some incompatibility issues in the chips that are built in those thumb drives. Oberon more or less recognizes them. But in this SanDisk Cruiser 4 gigabyte thumb drive, everything works. So it's a little bit like trial and error to find out which thumb drives works well and which does not. But before you can connect this thumb drive, you have to take care of another issue. That is that Oberon must be able to find the USB host system controller. And because Oberon is an operating system of the 80s and 90s, it's sticking to the USB host system controllers that were popular in this area. So modern USB controllers will probably not be recognized. But if you have an old system, PC system like I do, and maybe if you're running native Oberon, also you do, chances are high that your USB host controller will be recognized. And I'll show you a little bit more here on the system. Okay, because my SanDisk Cruiser thumb drive is already properly formatted, I'm using another one. I have a 1 gigabyte USB drive. It was a gift from a sales agent, and I want to show you the repartitioning
of these thumb drive on this example. So first I plug in the USB stick in a free USB port, and you can see we also Linux or Ubuntu is also already showing the contents here. We don't need them now. In Linux, namely in Ubuntu, I'm using a tool named gparted. Gparted is wait a moment. Gparted is a tool that can handle partitions, add new partitions, delete partitions, enlarge or shrink partitions. I think there are similar tools existing under Windows. I remember under Windows XP there was a tool for doing similar stuff in the system, somewhere in the system access. I don't know exactly. So under Windows you have to find your own tools, but I think the internet is full of suitable tools you can use. So I show you the repartition of this thumb drive under Linux. So first we have to choose the right drive. We have a selection box here, and this one here is the 1 GB USB thumb drive. Okay, and you can see it has a FAT32 partition, and before we can do anything we have to unmount it from Linux, because the file system is mounted, so we use aushängen, which means unmount in German. So now it's unmounted. Okay, now the USB drive is unmounted, so we are free to do our changes. At first we want to delete the FAT32 partition. We can do this by using the menu, or we can do this by using this button here. So now the partition is prepared for deleting, and the next thing we want to do is we want to apply a new partition, or we generate a new one, because the size of the USB stick here is just 1 GB, and FAT16 can handle up to 2 GB. We keep the size like it is, so we use the maximum size. So that means we won't change anything here in this this part of the menu. It will be primary partition. We can choose partition type FAT16, and we can name it, for example, Oberon. Okay, now we deleted, or we prepared for deleting the FAT32 partition, and we prepared for adding a new primary partition FAT16. Then we click this button here. Now we get a warning that everything will be deleted. We say OK. And now, after some seconds, everything worked very well. So you can see we have a 1 GB size FAT16 partition named Oberon. And that's all. So this is the same procedure you have to apply for USB stick, or choose an appropriate tool that runs under Windows. Okay, so let's start right away. I fired up Oberon, and as I said, we should start with the USB module, which is responsible for recognizing and connecting the USB host controller on your system. And this is a module USB UHCI.mod. This is the most basic module. Its special task is, and its only task is, finding the USB host controllers on your system and engage them. So let's open this module. And I won't go down the details here. There's very much stuff that's running around here in the background. I only understood a part of it, but the crucial part is going here. Okay, I hope you can see it properly. Yes. Here you can see a bunch of code which is marked as exported procedure init. So init is something, a procedure that is exported. It can be called from outside of the module. And what you can see is the consecutive calling of a function named Pci find UHCI. And as the name implies, this procedure is looking for a USB host controller. And in the commands here you can see that different kinds of USB host controllers, namely from the vendors Intel and VIA, are looked for. The system is searching for them. You can see two parameters here in the Pci find UHCI. The first one is a hexadecimal value, obviously, and the second one as well. And the 8086 doesn't mean something like an 8086 processor. This is a vendor ID. Every vendor has a special ID for giving his devices some kind of stamp, so you can identify it. And 8086 just means this is a device from Intel. As you can see here, the VIA chipset has another stamp. It's 1106 and not 8086, so this is just an ID. The other one here, 7020 or 7112, is another ID, but this is not an ID for the vendor's ID for the controller type itself. But you must see it as some kind of, let's see, the basement of a tree. There are several controllers running on a special architecture identified by this type of value here. Okay, so let's keep this in mind for a while. And before we can start by doing something here, we first have to see what kind of controllers we have on the system. And therefore we can rely on a special tool from Oberon, and let me see if I can find it. It's part of the system tool here, and it's Pci Tools Scan, this one here. So let's open Pci Tools Scan. Put our marker here just to open a new viewer, and then we invoke Pci Tools Scan. Okay, let's put a little more to the top of the screen. Here you can see some kind of analysis run that Oberon did on the system, and especially on, not especially, but exclusively on the PCI bus. It looks for everything that it can find on the PCI bus. And here you can see blocks of text identifying single devices Oberon found. For example, you can see here a network controller was found. You can see another Ethernet controller was found. You can see a display controller was found, which is a graphic card. And let's go a little bit down here on the list. Okay, and look here. We have a mass storage controller here, and we have a serial bus controller. This is a USB host controller, the one that found on the system. And you can see here, like it is written, it's from Intel. Vendor is Intel Corporation, and the device is 82820. This is a Camino 2 chipset. The most interesting part is here in the first line. When you take a look at this line, you can see this entry vendor/device, and you can see 8086. So this is the vendor ID of Intel, already as implied here in the text, because vendor is Intel Corporation, so obviously this here is the vendor ID. And then you can see another number here, 2442. This is a 4-digit number. For example, here you have also 8086. This is another serial bus controller and has a number 2443. And here 2444. So this seems to imply that we have different types of chipsets here working on the system. And if we go back here to our module USB UHCI, you can see we have this vendor number ID, and here we again have a 4-digit number. So what I suspected was that this 4-digit number here corresponds to the one you can find here in this line, which are the 4 digits behind, for example, 8086. And therefore I decided to give it a try, and I added another line. You see these lines here, all these ones are original lines from the USB UHCI module. In my try I added another line, and I identify it by this command. And this line here is calling the same function PCI find UHCI, but now I added this number here I found in the PCI scan tools procedure. Vendor ID is 8086 because it's from Intel, but now I added 2442. Okay, after I've done this, of course I stored the whole module and I recompiled it. Well, recompiling is easy. You just put your cursor here into the system log and you type compiler.compile and USB UHCI.mod. Don't forget the wave sign. Okay. Now this is done. The next time you start the system, the newly compiled version of this module will be loaded. Okay. Now, the next thing you want to do is, of course, testing if your change in the source code of USB UHCI.mod works or works not. So, this can be done by use of the USB tool. The USB tool is just a collection of known USB commands you can do for debugging and testing. So let's do script open USB.tool. Now the tool is opening, and you can see here in this line there's command USB.info. Just click it. What happens now is that USB trees connect sweep is running in the system. So the system is looking for connected USB devices, no, not for connected, it's looking for valid USB controllers which the system is able to recognize, and the information about this USB controller, if it could be connected or not, is written in the system kernel log. The system kernel log, as I already showed you in the past videos, is a log which is normally not visible because it already starts to log system events before the user interface is running. But there's a tool to take a look in this log at a later time, and this is also part of the system tool here. You have to click on System Open Kernel Log, this one here. When you click on it, let's shift this up a little bit, and now we go down the list. You can see all the modules here which were loaded and some stuff that is not very interesting. And here comes a line. Here you can see a register controller. after loading USB UHCI. This is the start of the module. And you can see here USB UHCI initialized, USB UHCI controller at base, blah blah blah, interrupt request 5 and so on, so on. These are your debugging is just a thing from me. I implemented in one of the USB modules, which is not something you should really be concerned about now. So just forget it. You can see the system found the USB controller at this base address and it could connect it. So when you find this here, after you've done your changes in USB UHCI, recompile the module and restarted your system, then you're off. That means you have a USB controller on the system that Oberon is able to recognize. Okay, so for the next step we have to insert our fresh reformatted USB thumb drive. I will connect it to my USB port. Okay. Now I wrote myself a tool, as I always do when I doing something on Oberon. Writing a tool tailored to your own needs is always the best way to get a system that is really filling your needs. Okay, so we do script open. Oh no, let's do it from the Oberon desktop. It's more fun. Desktops, open dock, and USB stick .mod. That was wrong, because it isn't a module, it's a tool. Okay, obviously this was my fault. Here you can see nicely formatted a lot of commands I arranged here that I use to connect to the USB stick. As I already told you, the USB stick now is inserted, so the system should be able to connect it. Here in the first block you can see the tools I already use a few minutes ago, the Pci Tools Scan and System Open Kernel Log. The next one here is starting the USB storage handler. This is a separate module in Oberon which is not started automatically, so you have to start it by hand. But you can insert it in the Oberon.txt configuration file, so at system start it can be invoked automatically. Now we do it by hand. So we click on USB storage install. Nothing more happens here. And now we go here to partition show, because if everything works correct, we now should be able to see the USB thumb drive, as the name implies, as a drive. And so it must be displayed in the partitions table. Okay, so now let's click partition show. And here you can see it. This is a USB SCSI disk. That is because the USB protocol is running through the SCSI Oberon modules, because SCSI is the most basic module for interconnecting Oberon with external drives. And you can see all those four Oberon partitions I made. To be exact, these are the four partitions I made on my USB stick, on my USB Cruiser one. At the start of the tutorial I showed you how to repartition a USB drive which was 1 GB. This was another one, so what you can see here is not what I did in the start of this video. This is what I did a few days ago. And you can also see the size here, and the partition type, which is FAT16, and obviously it would mount it correctly. So let's close this. And now we should be able to mount it, because it's now on the partition table, and before we can do something about it we should mount it. So let's do this one here, Filesystem Mount, and we will mount this first partition of the USB drive with the identifier USB. FATFS is just identifier for the FAT16 file system. So let's do this. And you can see here it's mounted. Already used is displayed here because I clicked 2 times here on the command. So, and now we should be able to access the contents of this mounted directory. I implemented some more commands here because I already made some subdirectories on this partition. One named Tools, another named Apps, another one named System. And there's a command here in the OFS Pci Tools module which maybe you remember from the first tutorials I made, because we used this module during the native Oberon installation process. So we use the function or the procedure change directory, and let's go to Tools, for example. Okay, now we are accessing the Tools subdirectory, and now we can do we can take a look at the contents here by doing system directory and giving USB as an identifier of the mounted thumb drive. So let's do this, and now I can see these are the contents of the USB stick on the first partition. I already copied some tools to it. You can see here the USB stick tool and some other stuff which is not important for now. So this works quite well. Oh sorry, I kicked the camera. The rest of all those commands here are for copying the files to the USB drive or back. You can see you can use the normal copy files from the system module by replacing these parameters here, which ones you want to use. This first parameter here is always the file to be copied, and then you have this equal sign and this greater sign seen as a pointer, and here comes the name of the file when it is copied and the respective directory. So when you want to copy something to the USB thumb drive, you always have to apply the identifier, which is here USB, and which was defined here in the Filesystem Mount command. Then you apply a colon and then the name you want to have for the copied file. And don't forget this wave sign here. And when you want to copy something from the USB drive to the Oberon system, it's going the other way around. You just exchange those parameters. When you're done with everything and you don't want to work anymore with the USB drive, you want to unplug it, then you should do this one here, this command, Filesystem Unmount USB. So now you can see it's unmounted. Okay, so that's very easy, folks. You see, we can use the thumb drive without getting into trouble by writing a FAT32 hardware driver, file system driver for the Oberon system. We can go around very comfortably with FAT16. It's easy to reformat a USB drive in FAT16. I hope you will find the respective tools for doing this in Windows, and you have far more memory space available on the drive that you are ready to fill with meaningful data in Oberon. So, that's all for now, and thanks for watching, and bye from the Oberon Channel.